welcome everybody. Um, I will start with the presentation. My name is Jose Liendro. Today we will talk about to create a private AI assistant. The technology that we will use is Ollama, Langchain, and Gemma, which is an open source Google LLMs. So if you like the content, please give us a like and subscribe. Here we have a list of the agenda. So I put some bullets here. First, to how to run a local LLM, what to consider. Talk about the RAG pattern, the architectures we created, the Langchain components, prompt engineering, and the observability layer. So this is just the agenda. So let's start. So first of all, I want to talk and to start from how to run a local LLM. And in this case, we choose Ollama to run local LLMs. And there are other options. For example, a common popular place is Longchain. It's Hugging Face, which it works as a repository of the LLM images. But we choose Ollama servers to simplify some configuration at the times you download and use the models. So Langchain works as a service and as a repository for the LLMs that we want to use. So things to consider. You can use Ollama in a computer that can have or not a GPU. So it's not a restriction to install and to download the models or even to use the models. But during the experience, you will notice that to create embeddings and to extract valuable information from the models, it's like a must to have a GPU in place. And that will reduce a lot the times of the processes to create embeddings and the answers for the questions. So here we will see that Ollama works similar than Docker because you can download all the LLMs as images and they have tags that they describe the size of the model and some configurations that they can have. Let me try the pointer. So we were talking about this. Even one single model can have like multiple versions, multiple size, multiple configurations, and even it can be trained to work better for chats or to infer knowledge. And depends on the resource of the machine that you are using. Maybe you will choose one or another, or if you want to have like more power or more accuracy, you can try with the same model, but with a bigger. So then during the experience, we tested Ollama in a Mac machine, in my Mac machine, which is an M family. I have a M1 family. And some items to share with you. Ollama can run like locally as a service in your machine, or can be used from a Docker image, but it has some limitations to run as a Docker image using your GPU for your Mac GPU cores. So if you want to use Ollama in your Mac with an M1 family, at least in March 2024, it's a better choice to use Ollama as a service and not using a Docker image. Even though, on the other hand, if you are using, for example, Ollama in a Linux system that has like a GPU enabled, Docker has the option to share the GPU core to the image, so that is possible, but not at least for Mac family. Then when we install and we want to run a model in an EC2 instance, this is the type of family that we were using, the G4 GNX Large, which has in this case one GPU enabled. Things to highlight here, when you are choosing to use this kind of instance, you will see that there's an option in the MI that already have the NVIDIA drivers in order to use the GPU cores. So once you choose that image, and then you need to select the instance type, you have the GPU core, and then probably you will need to request permissions to AWS to start working with this type of machine. This takes like a couple of hours. And then this is another note regarding Ollama, that when you are running a model in your machine, in order to improve the performance, they recommend to load the model in memory the first time, and then you have the model enabled to give you answers. The default port for Ollama is 1.434. But when we were configuring our services, we detect that this port number doesn't work. It has some network connectivity issues with our services. So as a workaround, what we did is to choose a lower port. In this case, we use like the 8080 port in the security group, configure Ollama to change the default port instead of using the default, use the 8080, and that works pretty fine. Another things to highlight in terms of the EC2 to run in this case, LLM instance in an EC2 machine, is that these instances are expensive. So for example, the default ENF large has like a $400 by month. So when we configure this type of instance, and if we are using, we can enable the resource scaler, which is a service in AWS that allows you to create some schedule rules so you can manage the instance state, so you can start or stop the instance in working hours, for example. So you can have the server up and running in working hours, and during the weekends or at night, you can just stop the instance. So here we have some screenshots about how this Ollama server works. So as a service, you will start Ollama to serve. Here you will see that at least in Mac, to refer to detect if the Ollama use or not your GPU, it will refer to the Metal API. So once the Metal message is here, you will notice that the GPU is in use. And if not, he will say that the GPU are not enabled as a warning. Then you can download several models, as we said. And here we have example, we have the Gemma, which is the open source LLM model from Google. And the official, the mainstream model is Gemini, which is a paid option similar to GPT. Then here we have Llama 3. We know that depends on the model, we can have like different sizes that will impact in the amount of tokens and the context that the LLMs can manage. So the size will be determined by the first tag here. So 2B or 7B. For example, Gemma 2B is like almost 2 gigabytes, and Gemma 7B, it has like 5.2 gigabytes. Then as well, you will see that in the tags, you will have the instruct word. That means that this model was fine-tuned to work to have a better performance in a chat experience. And this Q4, it's related to reduce the way it's to use less resources. In case you have some limitations in the resources of in the machine that you are running the LLM. And lastly, you will see here that with the model, you can start working out of the box. So you can run Ollama run Gemma 7B instruct and start talking with start requesting some tasks to the LLM. And as you can see here, I ask about who is Argentina's president. And the first time it says that it cannot answer the questions you are an Argentina president. because it doesn't have like up-to-date information. But the second time that I ask, it responds with an out-of-date information. He says Alberto Fernandez, and today is Javier. So here we have several things. First of all, these models are not deterministic. So with the same questions, we have different, we can have like different responses. And well, so that's it. So here we have as well a limitation, because if we want to have more updated knowledge base, or if we train the model with private data, we have a limit, at least in this first approach. So then this is an example, and that's just an example about to run a model that in an EC2 machine that is not from G4DM family. So as you can see here, my personal computer, in this case, I want to create embedding for a file that like a pretty small file, and it takes like 2 or 3 minutes. But if I want to do the same in an EC2 machine, in this case, in a T2X large with 4 CPU and 16 megabytes, the same process take like 1 hour. So the difference is very important here. So this process is just to create the embedding. If we want to try and to request some responses from the model in a local computer, in this case in a Mac 1 that has like 14 GPU, it took like 20 seconds to create a response that, of course, if we are talking about services that connect each other and creating requests, we will create a timeout. And to create the response will take like 20 minutes, so it's not acceptable. So because of that, of this limitation about how to ingest like more outdated, more up-to-date information or more private information, we can work, of course, with the local model, and we can work with the RAG pattern in order to have a knowledge base that we can ingest data. So then we can ask to the model to create better responses. So here we have like the 3 main use cases that the RAG pattern has. So first of all, if we have like documents here or information that we want to process, it will offer a process to extract information from a document lake, data lake, let's say. So if we can ask and we can ingest the documents and extract the topic, the summary, the author, and in that way we can enrich our knowledge base with metadata. Then we have a conversational agent or Q&A strategy where when we have the knowledge base and we are asking through an agent to retrieve some data from our private knowledge base. And lastly, we can ingest the AI process in a workflow. For example, in this case, we have an inbox. So once we read an email, we can read the email and suggest like a possible response, or even to send a response back. And we can create, in this case, automations where we will have a step produce output using the models. In this case, what we choose is the second options, the Q&A system. And in order to make this happen, there are 2 main processes. The first one is to create a private knowledge base. So we have information, we split the document in small pieces of chunks in order to create embeddings. And that embeddings, this first transformation goes from text document. We split it in small sizes and translate it to the embeddings, which is the information that the model can manage. So this is the injection. We will store it in a vector database. And then once we have a question, there will be an algorithm that we will search through in the vector database to extract the chunks that are more related to our questions. And once we have the chunks and the question, we can use the model to create a response for the question. So this is what we did. This is our simplified solution. We use Copilot, in this case, AWS Copilot, to install the architecture. So we will have, in terms of Copilot, we will have like 3 different type of services. We have a load balancer web service, we have a worker service, a backend service, and then here we have just an EC2 machine that runs. I put here OpenAI with GPT-4. So if we want to use like the same structure, but against GPT and OpenAI, we just replace Ollama my GPT-4 and will work as well. So here we are accepting like HTTP request, and the first flow is in charge to create an ingest process to create embeddings. So here we are sending text documents. We get the embeddings from the model, and then we will store that embeddings in and the second flow, what it does is to create a response. So with the question and with our vector database, we create and the model, we created a response for the user and send it back. So this is the simplified solution, so it's easier to see what we are proposing. And this is the extended one that has for example, it has another component, but the ones that I want to highlight are the components that, for example, connect one service with the other. In this case, we are storing documents in S3, and then we have a queue. So the worker that is responsible to create embeddings can take the documents and create the embeddings and to store it in the vector database. In this implementation, we use Postgres with the PG extension. Here we have the EC2 machine with Ollama server, and that it has the Gemma Google LLMs. And at the right side, we will see that we have the AWS resource schedule, where the way that it works is using tags. So whenever we put some tags to a resource, that could be, in this case, we are using the resource scheduler, so it works only for EC2. So we are tagging the EC2 machines that we want to control through the resource scheduler and create some rules. So we define the time range, and if we want to being up or down, and just it works. Okay. Main component that we are using is Longchain, which is a framework that help us to create the agents and how to help us to interact with embeddings and to do prompt engineering against our data. So they have like 3 main components. They have the Langchain framework itself. They have the LangServe, which is their proposals to store the application. You can run your agent in the LangServe, and as well they offer the Langsmith, which is the observability layer, so you can understand and debug what your agents are doing. The agent here, it's an entity that will look for information in your vector database. So when we are talking about prompt engineering, there are a couple of things to consider. First, we have a system prompt where we are giving to our agent some personality or profession, and we say something like, for example, you are a cooker, or you are an architect, you are an engineer, you have some years of experience, you want to work this way, you like to have responses like this, you want to format the response. We are describing all these things. And then regarding the model itself, there are some components to manage. We have the temperature. Typically, with the temperature of the model, we are saying like if we want to be creative or not. And then we can have like different algorithms to extract the more related embeddings. So typically we have the similarity search or the MMR search. So there are different ways to, once we have in this diagram, once we have here an embedding database, and if we have a question, we will do a similarity search to extract the more related chunks. This algorithm can change and can have like different parameters, and that is one of the aspects that we want to manage here in the prompt engineering. Then we have the agent itself. We have here options. We can have the agent or not, and as well we can have multiple agents. And in each agent can have like one or multiple tools. So in the example that we have at the beginning, where we are asking for the president, Argentinian president, and typically when we are going through the examples of these patterns, typically we will have an agent that have a couple of tools that help us, the LLMs, to create a more accurate response. So for example, the more typical are to manage like mathematical operations and to look for internet if they don't have information. So for example, in our example, if they want to know who is Argentinian president, he can goes to Wikipedia or something else to extract like a more accurate data and bring it back to the agent so that he can create a more accurate and complete response. So here we have the observability layer. As well, we implemented the configuration. This works similar to the APM agent in Elasticsearch. So our application, what it has is an API key that sends data to Langsmith. So when we open up Langchain, we will see an interface similar like this, where we have a set of projects that we configure, and we will have a lot of statistics of how our implementation works. So in this case, you will see that once you go to your project, you will see a list of all the questions that you did for your in your implementation. What I found interesting here is that well, first of all, you will have a track of all the questions that goes through then we will have here a column that says cost. So as you can see here, the column is empty because we are using the local LLMs. But if you are using ChatGPT, for example, you will see here that how much each of these questions costs, and then the amount of tokens that the query use, and as well the time that takes to create a response, and as well general statistics about how the chat works. And if you go deeper, if you click here in one of these questions, you will see in particular how the agent works. So here, for example, we made a question, read the RPG and create a bullet summary of what the code is doing. And so this is the human, and here in this instead, we can see how are the documents that were extracted from our private knowledge base. In our first, in a previous step, what we did is to ingest code base written in an old language with the name RPG. So once we have a question, the agent, what it does is to looks in the vector database and create a vector from the question and extract this information from the vector database and then create a response. If we are going deeper in what the model is doing here, we will see and have a detail about what happened and what is agent. In this case, we will see the definition of our system prompt. In this case, you are an IBM RPG expert. This is the way that we are defining how it works and how we want to retrieve data. And here we can see that we have the documents that they found more related to here we have the user ask, and finally here we have the response back to the user. So, well, in this case, we cover how to understand and debug how it works, because sometimes I think one of things to highlight here is that the process is not deterministic. So if you make the same question multiple times, you can get like different responses. And then actually we have different ways. We have a kind of long graph that propose to have a more deterministic way to create the responses. But well, this is something that we need to try. But at least in this opportunity, we were able to create an agent with a vector database and as well with a local LLM model. Another thing as well to highlight is that today we have a set of new models in the industry. There is a tendency that the models are bigger and bigger. We have Llama 3. We have Llama comes from Facebook team. Gemma comes from Google team. We have Mistral that comes from France. So there are a lot of models that we can use these days to test our application. And another things to highlight is that we can run the models in our computers, and we have GPU, NVIDIA drivers, or Metal API in Mac. And as well, we can run the models in an EC2 machine or in a batch process. So we have like multiple options to enrich our workflow with. So this is the end. I'm not sure if you have any question. Feel free to ask. Okay. I think we don't have questions. So that's it. Thank you. Thank you all. So I hope you see you in another OTP. Bye bye.